You see, in some of the cases, if I consider the first case, okay, the first case. In the first case, the momentum was initially the momentum was towards the right side, and the change in momentum was also towards the right side. Agree? Okay. Let me scroll down to the next thing. So in this example, the momentum was towards the right side, but the change in momentum was towards the left side. Okay, let's consider this third example. In this example, we started from this side. This is the initial state. So the momentum was towards the left side, but the change in momentum was towards the right side. And let me consider the next example, the fourth one, third, and then the fourth example. And in the fourth example, what you see is we started from here, from this side. So the momentum was towards the left side, and the change in momentum is also towards the left side. Now the question is, the big question, is there any general statement that we can create that would relate us, or that would help us to comment on the direction for change in momentum? So depending on the initial condition and depending on what happens to the sphere, especially related to the motion of the sphere, could there be a general statement that we can create here that could be used to explain the direction of delta P, that would explain the direction for the change in momentum? Or in simple words, if I phrase it in simple words, what I want to know is, in what situation the delta P, the change in momentum, aka delta P, would be towards the right side, and in what situation the delta P would be towards the left side. That's pretty much it. Yes, you're totally right with it. If u is less than v, and if u is less than v, then can I say if we are speeding up? Because think about it, if u is less than v, that means v is greater than u. So final velocity is greater than initial velocity. Okay? So if final velocity is greater than initial velocity, it means you're speeding up, right? And if you're speeding up, then you can simply say the change in momentum would be towards the right side. Let's try to apply this thing, and let's try to see if this is applicable to all the examples. So we were speeding up in the first one, momentum was towards the right side. Okay, we're slowing down in the second, momentum was to the left. We were slowing down in the third option, the momentum was to the right. Okay, so how about this thing? Do you think this statement would be compatible, or this statement, whatever you have said, explains this condition as well, the case 3? Why not? Okay, object is slowing down and still the momentum is towards, the change in momentum is towards the right side. Okay, so let me put it this way. What if we do come up with a general expression that looks something like this? If you're speeding up, all right, if you're speeding up, no matter in what direction, you might be speeding up towards the right side, or you might be speeding up towards the left side. If you're speeding up, then your delta P will have same direction as momentum. How about this thing? Just try to check it out and try to relate it with the cases that we have here. So what I'm saying is, if we are speeding up, then whatever the direction of the momentum is, the direction for the change in momentum would also be the same. So what is that? What that means is, if you're speeding up towards the right side, delta P would be towards the right side. If you're speeding up towards the left side, then delta P would also be towards the left side. Example. Now let us try to relate this explanation with all of them. If you're speeding up to the right side, the delta P has to be towards the right side. Is it towards the right side? So if I'm speeding up towards the left side, delta P has to be towards the left side as well. How about the last example? Okay, and the ones in the middle also can also be explained by this pointer. So if you're slowing down instead of speeding up, then whatever the direction of momentum is, the direction for the change in momentum would be reverse of it. So for example, in the case 2, the direction for the momentum was towards the right side, but the direction for the change in momentum is towards the left side. And likewise in the case 3, the direction for the momentum was towards the left side, but the direction for change in momentum was towards the right side. So this is a general statement that would be applicable to all of them.